Welcome back, everybody. Please take your seats. Please take your seats so that we can start. Welcome back, and welcome to everybody who's new here. So I would like to hand on the microphone to Andrea. She will introduce our special guest.
Yes, good evening. I would like to introduce a special guest for our evening lecture today, Silvia Devescovi from Terre. Welcome, Silvia. We are very happy that you came all the way from France to Vienna. Many earth builders are looking to France, and the Terre factory is kind of really fascinating, and we are wondering or hoping that this might be a prototype for many other factories to follow, and that this concept would allow us to produce earthen materials really for a broad market in future. So this is what makes it so fascinating and interesting. And so we are very curious to learn more about this interesting endeavor that you started there. But before, let me briefly introduce you to the audience. Silvia Devescovi is of Italian origin. She studied communication at the University of Bologna, completed by a training in urban planning and city management at the Institut Urbanisme de Paris. And she has been working in France since 2006, first for a social landlord on urban renewal issues, and then in a local authority where she managed urban planning processes and complex development projects. On behalf of the city of Sévran, she piloted the Terre project to create a raw earth materials factory in Île-de-France, using excavated earth as raw matter. She is now working on circular economy and ecological construction issues, in particular in support of the earthen construction sector, and with a specific attention on training topics. So, thanks again for coming to Vienna, and we are very much looking forward to hear your lecture.
Thank you. So first of all, sorry for speaking English. And you should know that it was very frustrating for me not to speak any German at all, so that you had this great day with so many lectures and discussions, and I arrived 10 minutes ago because I couldn't understand anything. So it's a pity, but maybe in 5 years' time I will speak German. So my presentation, I'm going to speak, of course, about Terre. So what is it and how did it come about? And then I will try to speak a little bit about the impact that Terre had on the earthen construction sector in France, and also try to see what comes next, even if it's very difficult to know. So first of all, Terre, what is it? It's a private company, it's a factory, which has been operational since the end of 2021. And originally, it was created by a consortium led by a city. So this is quite unique in the sense that today it's a private company, but the city I used to work for, Sévran, was actually at the origin of the project. And it's actually still one of the members of the company. It's a city that is in the northeast of Paris, and I will tell you a little bit more about that later. When we started to work on Terre, it was at the beginning of 2017, and we had the idea, because there was an exhibition in Paris at the Pavillon de l'Arsenal, which is a very important place for architecture in France, in Paris. And there was this exhibition about earthen construction from a slightly new perspective, as the idea was to show that earthen construction could be a contemporary urban material, and also that it could be, we could use not just the soil beneath our feet, which is the tradition in earthen construction, not just the soil beneath our cities, but really the soil beneath Paris. And it was a bit of a provocation or a revolution because people have a tendency to think that the soil in Paris is polluted and that it's everything but natural, that it's totally artificial and probably polluted. And it's not necessarily. This is the image we have, the representation we have, but if you go and make tests, analysis, actually the polluted fraction is 10 to 20%. So there is a lot to do. And there is a lot of digging happening in Paris. And this is the first reason which brought us to work on this project, is that there is a huge problem, as in other large cities, of excavated soil. So you have a drawing here. The bigger pyramid is, wants to show the volume of excavated soil from building sites in the Paris region over 15 years. And the smaller pyramid is only the excavated soil coming from the Grand Paris Express, the new metro line in Paris. So you can see that we are talking about huge volumes, and I'm sure you already know that Terre is not going to solve the big problem in terms of quantitative. In quantitative terms, it's just not comparable. But from a qualitative point of view, then it's very interesting, because we are really taking into account the qualities of the soil, of the earth itself. We're not just putting it somewhere. We are really giving a value to the quality of the soil. And so it brings me to the second set of reasons that brought us to work on this project. And I'm not going to develop on any of this because I'm sure that after this day of studies, you are all very much aware of all these qualities. So we had very good reasons. We had the idea, we had the reasons, the motivation. And what really helped us begin the project, of course, was a funding opportunity. There was a call for project by UIA, Urban Innovative Action, an European Commission initiative. And we decided to apply for this. And why was the city of Sevran the project manager? Simply because these funds belong to the ERDF funds, so they target cities. So the partners needed a city to apply for the project. And the city of Sevran said, okay. So why did the city say, okay, I want to do it? Because it was formerly an industrial city in the northeast part of Paris. And the whole northeast of Paris used to be industrial and is no longer industrial today. So what is left is a lot of poverty, a lot of unemployment, a lot of brownfields, polluted sites. So it was very interesting for the mayor to say, we are going to bring manufacturing back into the city. And this was also interesting for Europe. Because, of course, you all know that other things were going on in Europe about earthen construction. We were not the first ones. But the fact that it was in a big capital like Paris, and paradoxically in a poor area, it was very interesting for the European Union in terms of skills and jobs and skills development. So the partners that apply for the European funding are those. We were 13 of us. You probably don't know many of them as they are all French, but I'm sure you know the ones on the bottom. Terre, the University or Architecture of Grenoble, and Amaco. And the others are a mixture of architects and private companies, a private promoter, public promoter, and research labs, and also one NGO. So we got the European funds. But this came with a big constraint, a big difficulty, which was the planning. We had only 3 years to develop and implement the whole project. And when we started, we didn't even have a site. So it was a very short time. We started in March 2018, and we were supposed to finish by March 2021. And what happened is that we got lucky. Sorry, this is really a bad joke, but COVID came, and COVID-19 gave us the opportunity to negotiate with Europe. You don't negotiate so easily with the European Commission, but COVID gave us an unexpected possibility of negotiation. So in the end, we were lucky enough to have 8 months more. So we started the project in March 2018, and we had a launch conference in the same place where the Terre de Paris exhibition had taken place, so Pavillon de l'Arsenal. And it was really impressive because we had 400 people attending for a project which had not even started. We didn't have anything at the time. It was just a vague idea, and 400 people turned up. So we had the feeling that there was a lot of expectation in Paris about this whole thing. And then there is something hidden here on this slide. As you see that we filed a building permit in November 2019, but actually something happened before. We filed the first building permit in July 2019. It was the 3rd of July 2019, and on the 4th of July we received a defavorable report from an inquiring commissioner. We had to change the land use regulations for the site, and it just went wrong. And we learned it the very next day after the building permit was filed. So we were already 18 months into the project, and we suddenly knew that we had to change site. And we had maybe, 1 month to find a new site. And on the 21st of July, we had a meeting, and we chose a new site. So it was, in the end, it's a good story because we managed to do the project, to realize it, but we went from 10,000 square meters to 2,500 square meters. So the whole project surface was divided by 4. So in November, in spite of this, the architects were able to file the new building permit for the new site. And then the works started in July 2020. Then in spring, we started to obtain some certification files that are very important for the use of the materials from a performance and security side and from an environmental point of view. And then in July 2021, the building was absolutely not complete, but still we started to receive the machines because we were on a very tight schedule. And then, so the project was supposed to end on the 31st of October. We had a visit from Europe on the 21st to see that everything was finished. So we spent the night working in the factory to make everything appear finished. And then finally it was okay. The reason why it was so important for us to finish on time is that otherwise we wouldn't have been able to get the full grant. And now here on this slide, you can see why it was important for us to get the full European grant, because it represented almost 80% of the total funding. So it was really a huge opportunity that we had. The overall budget was about 6.5 million euros, and the European funding was almost 5 million, and then the rest was some regional funding, some funding from a housing company in Paris, and the rest was the partners' contribution. And if we look at the expenses, you can see that's about two-thirds. It's investment, building, and machines. When we started the project, the building was supposed to be a very light building, almost no building at all, like a roof with some machine under it. And in the end, it turned to be quite different. So I'll speak a little bit about that, why we changed. And then the rest was more soft work, like earth environmental analysis and earth characterization, product and process design. And this cost a lot because it includes certification, standardization files. We had evaluation of the project itself and of the environmental impact of the materials. And we also had training, but not as much as we had planned in the first place. So I said that the budget for the investment for the building especially increased over time. And so this was at the expense of the training budget. So in a sense, we had no choice, actually, because our first deliverable for Europe was the building itself, the factory with the machines, so we had to do it. We had no choice. But there was also another reason why we could decrease the budget on training, and that's because our main goal was, of course, architects, but not just architects, it was building companies. The main budget was for building companies, for training. The problem is that you cannot already, it's very difficult to convince building companies to get some training. And if the materials are not even there yet, forget it. You will not have a company come to your site and do a training where there is no material available. So we really had to wait for the factory to be operational before we could start the training program. So this is something I'm working on today. And then about 700 euros on project management and communication. And this might seem a lot, but you have to bear in mind that it was during 4 years, and we were 13 partners. So the project at the beginning was a very integrated project. The whole idea was to do all the different tasks, all the different actions on the same site. So digging and selection, storage and preparation, production and using construction, all of this in one building site. But it didn't happen that way in the end. There are different reasons for that, and to be honest, there was not one moment in time where we really rationally took the decision to change the model. But one of the first reasons is that the site that we had chosen for have this beautiful integrated project, while the owner of the site didn't want to have a production facility on his site. It was the site for one of the stations for the underground new metro line. And they wanted their metro line to be ready for the Olympics in 2024. So they had a big challenge on planning. So anything new, anything that could in some way disturb the planning could not be accepted. So we had to choose another place. And there we realized that actually it's not such, for us at least at the time, it was not such a good idea to have a production site that is totally dependent on one only building site. Because it means that you have only one supplier and you have only one client. And it's not a very good balance for an economic activity to have only one supplier and only one client. So in the end, the factory that exists today can receive soil from different building sites, and it can also sell the materials to many different customers and projects. And there is something else that is important. When we were thinking about this very small size project, very integrated, we had in mind something very light facility, as I say, just a roof and the machines below the roof. But that doesn't give a very good image of the raw earth sector. In a city like Paris, our goal was to upscale, was to convince people who are not convinced already, who do not have a strong ecological motivation, who do not have a big interest in natural materials. We wanted people who are just normal, basic builders to be able to use the materials. And for that, we needed to take care of the image of the factory also. So it's a beautiful building, you're going to see it in a while. And I think this is really important to give a good image, like a showcase of the whole urban sector. So now I'm going to give some details of each of those 4 parts. So we're dealing with circular economy, which means that the first part is maybe the most complex part. Digging and selection. In France, there are a few producers of earthen materials, which are also producers of fire bricks. And these people, they have their own quarry, most of them. So they already have the supply available, and they just need to change a little bit their production process to use it in another way. But here we need to deal with different excavation places where we have no control over the planning, over the timing, over the quantities, over nothing actually. So this is really the most difficult part. The first thing we had to do was to have a look at the geological characteristics of Paris. So here you have a map of the Paris Basin, which is quite wide actually. It goes almost up to Germany, the Vosges, Alsace, and then in the north it goes up to the La Manche, the Channel, and actually Paris is really in the middle, in the yellow part in the middle. And if you see a section, you can really see how this is a collection of sedimentary layers, which is very diverse. It gives a lot of a diversity. And some geological strata, which are very low and are not close to the surface, in the middle, for example, they become close to the surface on the outer parts. So depending where you are, it's not the same composition at all. And if you zoom in a little more, you can see that even within each strata, there is a lot of variety. The whole section is about 3,000 meters deep in the deepest part. But of course, we are not going to excavate on this depth. So the part that we are concerned about is the yellow part on the surface, and it's about 250 meters wide. And I think that the tunnels for the Greater Paris metro go up to 40 to 60 meters deep. And even if you are very close to the surface, there is a lot of diversity. Here you have, for example, sand of Fontainebleau, oyster marl, limestone, green marsh or green clays, white marsh, and then you have gypsum. And then below the gypsum, you have some more earth. So it's really very composite and very diverse, which is why Amaco, one of our partners, had to spend a lot of time on analyzing the soil. And each sample had to be tested to see if it was good for construction. And so I'm going to go a little bit into the criteria that made us choose one type of soil. So we needed a maximum of cohesion for the materials, mechanical properties, especially mechanical resistance. We needed a minimum of shrinkage so that we didn't need to add too much sand and gravel. We needed maximum homogeneity because, as I said, we wanted to upscale. So we needed a large-scale process, and also we needed to have certification, and we knew that the certification body was expecting some homogeneity. And we needed the materials to be available in large quantities, and also ideally at the right time, so that the production line supplies would arrive on time. And we needed also the soil to have a minimum of water content, which is a big issue, at least with the climate today. Up to now has been a great issue in the Paris region. The machines that we use for crushing and grinding and mixing do not work well with very wet soil. So we need the soil to dry before it can be grinded. And so either it takes energy or it takes space and time to dry. So for the cohesion, as you know, the cohesion is important. It's basically in the natural soil, it's given by clay, and it's important for the mechanical resistance of the materials. Shrinkage is also important. The soil we tend to have in the Paris region, there is quite a lot of clay and limon. So it can give rise to quite a lot of shrinkage, as you can see here. And so we knew that we had to add some sand and stones to give it some structure so that the shrinkage is lesser. In the end, we could find a soil type that was okay, but still we do have to add some. We wanted to have a maximum of homogeneity, as I said, because we needed to have a large scale process. And as you can see here, this is an example of core drilling in Sevran. It's very difficult to find good homogeneity because there is so much difference. The lines on the, so it's one sample, and each line corresponds to 1 meter in a sequence. So you can see visually that there is a lot of difference between 1 meter to the other. So in order to have homogeneity in large quantities, you need to go horizontal. You need to have a big enough site so that you can have a more or less homogeneous sample. And also what you can do, what we have done, is that you can move the soil so to make it more homogeneous once you have it. So it was important, as I said, to have a good quantity of materials for the production lines. And also we needed to have a minimum of water content, as I said, because the machines which have to crush or to grind the soil do not work well if there is too much water. So in the end, after crossing all these criteria, we were able to find one type of soil which was working pretty well. It was, of course, not perfect. And I would say that the criteria that is the least favorable is the one about shrinkage, meaning that we do have to add sand actually to our materials, especially for the compressed block. So it's about 70% earth and 30% sand in our blocks today. But at least these materials, this soil is available in large quantities, very close to Paris, very close to Sevran. So this is very important. And it's got very good mechanical resistance. And we know many working sites that in the years to come are going to produce exactly this type of excavated soil. So once we have the soils, then what do we do with it? When we were still working on the project, the factory was not there yet, we realized that we absolutely needed to have a store, we needed to have a stock of soil, because we couldn't wait for the factory to be operational to start digging. But we had no place to put the soil, so we decided to create a homogeneous stock just on a building site, a very big building site. And then we covered it, and it stayed more or less dry, more or less, but still it worked. And then a few months later, one of our partners was lucky enough to find an empty an industrial building that was not in use anymore, and he rented it to store the soil. So this is something very important, and in my opinion, it's one of the things that could be mostly improved in the next project. Because, as I said, the soil in Paris is quite wet, so it cannot go right into the machines. And also we wanted to have big quantities of the same homogeneous soil, so we could not just wait for the trucks to arrive every week. We needed to make a big batch, at least, I would say, 2,000 tons of soil at a time, of homogeneous soil. And as it's not dry, we had two options in order to dry it. The first one was to use machines, so with artificial drying. And the second one, which is the one we chose, was to put it somewhere where there was no rain and just make a very thin layer and wait for it to dry naturally. And of course, when you compare the carbon footprint of the two options, the second one is the best. It's the best, but it's not ideal. It's the one we chose because at the time it seemed the best option, and anyway, we had to choose something. You know, when you work on a project with you all know that already, when you have a very short deadline, sometimes you just have to make choices, and you don't have to make the time to make the very best choice, you just have to go on. So this is what we did in this case. And the reason why I don't think it's a very good option in the end, or not the best possible one, is that, first of all, of course, the carbon footprint is lower because there is no energy involved in drying, but still it occupies space. So you might imagine that you can have a park here instead of a big warehouse. And the second reason is that it doesn't make the project attractive to people. You will see later pictures of the factory, Terre. when people come to visit the factory, if we invite mayors from other cities to come and visit, they are all very happy, and they say, I want the same one in my city. But if you invite them here, they will not say, I want the same in my city. So it doesn't give a good image, and it's something that it's difficult to place in urban context. So it's something that could be an obstacle for the reproduction of the project. There is basically only one machine here because we decided that we just needed one machine to grind the soil. And this is a scheme or how it works, more or less. So you have some places where the soil is being dried, and then it goes through the grinding process, and then it's separated. Some of it is grinded to 1 centimeters for the compressed blocks, and then some is grinded to 2 millimeters for the mortar and the plasters. And then so we need to keep even once it's grinded, we need to keep it there because there is not enough space in the factory. As I said, we went from 10,000 to 2,500 square meters, so there's not much room. So it's just maybe 1 or 2 trucks a week that leaves this site and goes to the factory. And so here we come to the factory. Here is an axonometry of the project. As you can see, it's a small plot and it's surrounded by buildings. The buildings on the right is actually 2.75 meters far, and I know this because we had a lot of problems during the works because the people working there were complaining all the time because of the works. But something that is very good today and gives some optimism is that there has been no one complaint since the factory has been operational. So it's really possible to put an activity of this type within an urban site. And there is a beautiful park behind the factory, and you will see it on a picture. It gives a very nice atmosphere to the building. So now we are going to look at a picture from number 1, the entrance of the factory. You can see trucks come in from here on the left, and maybe you can see that there is a first floor, a wooden first floor, and it's a circulation area, and the whole facade is very open to the external area. And this is so new for this area. It's in an industrial place, so it's like shoe boxes, all of them, very closed building, no communication at all with the outer environment. And here it's so nice to have a building that is open to the external environment. Now we're going to look at number 6. So here is the entrance for the trucks, which carry the raw earth, the raw earth itself, and also it's a storage place. As there is very little space for drying materials, very little space at all, we needed to put storage on every wall. And also on the right-hand side, you can see that we had the possibility to close this part. It's a drying, we call it a drying tunnel. So the central part of the roof is translucid so that the air gets very hot. And then there is an engine that aspires, that brings the air into this tunnel so that the materials can dry in half the time. We go from 4 weeks to 2 weeks. And this is very important to keep production going. So you know that the materials cannot leave the site until they are completely dry. Otherwise, they are too fragile. Number 2 and 4, it's the place of storing the raw materials. So as I said, there is mostly earth, but there is also some sand, very small quantities of cement for the stabilized material, fibers, straw mainly, and cellulose. And you can see, here. So this was planned to be a small storage space. As I said, we had to reduce the budget on training during the project, but now we have found new funds for developing training opportunities. So actually, we decided to deliver one training program in the factory, and as the factory is not working at full speed yet, it's going, the technical part, the practical part is going, to be here. And it's going to be an 8-month-long training, especially on plaster and wall decoration. Then you have number 3, you have the mixing of all the raw materials, and number 5, you have the production. And so the main machine is the production of the compressed blocks. So the machine was designed by Etienne Gay from Brick Technique Concept, and he did something new for us. He had this machine already for himself, but what he did for us is that he made it work with a robot arm for the palletization. So the press compresses the soil, the earth, 3 blocks at a time, and it measures 2 things, 2 parameters. First of all, it measures the height of the materials, and then it measures the compression, the mechanical resistance. And according to the result, if the result is good, then the robot will put the materials on the pallet. And if it's not good, the materials will go back up in the basket over here, here, so that they go back into the process. And then there are 2 small machines, very mechanical. So this just work with gravity. This is to fill, it's a filling station for big bags of plaster and mortar and pre-formulated soil for example, rammed earth. And you have a smaller machine on the back here. Here you put a big bag on top, and then it will fill smaller bags. So this is the scheme for production. You have the raw earth that comes in, it's been received, it's been stored, and then you have 2 options. You have a dry mixing on the right for mortar and for plaster. And for mortar, you will mix it with sand, and for plaster, you will mix it with fibers, with straw. And on the left, you have a wet mix. Sometimes you add water. Sometimes you don't need to add water if the air is humid enough. Then sometimes for the blocks, you always add sand. And in very small proportions, about 10% of the whole block production, they will add cement. And in the middle, you have a new product that is being developed, earth fiber panels. I'll show a picture of them later, which are being extruded and then dried and then stored. And they mix earth and fiber. So they're very interesting for many reasons, but also because there is no sand used here. And then you have a first floor, number 9, 10, and 11. So number 9 is offices. Number 10 is just a circulation area, which is very open and very nice. It's a nice place to be. So people who come visit the factory, they tend to spend a lot of time there. And number 11 is the laboratory. This picture was taken, I think, when it was not full of machines yet. So it doesn't look exactly the same today. But basically what they do there is they test the earth itself. So as we are working with different types of soil all the time, they have to make different tests. And then they are also testing the materials themselves after production. And finally, we come to the use in construction of the materials. As I said, the main material is compressed earth blocks and, of course, the mortar that is necessary to build walls. The wall on the right-hand side is the wall from the factory itself. And you can see that there are 3 sizes at the moment, 15 centimeters wide, 9.5 centimeters, and 22 centimeters. And as I said, most of our materials are non-stabilized. Only 10% are stabilized. The idea is to encourage designers, architects, to conceive buildings which do not need stabilized material, but only maybe a first layer of stabilized material so that the capillary rise will be dealt with more easily. During the project, we decided to devote quite a lot of money to standardization. And this was a decision that went together with the upscaling idea. So it's not necessary, it's not compulsory to have these types of documents, but it does help if you want your materials used to be massified. ATEX, so it's an acronym that means Appréciation Technique Expérimentale, so experimental technical appreciation. So it's an appreciation, it's not an authorization. Again, it's not compulsory, but it helps a lot because the insurance company, once you have this, it will just, there are no questions asked. It just goes directly into acceptance. And if you do not have these documents, which are pretty expensive to obtain, especially on the type we obtained, then you will have one person, one professional on the project, which is called a technical controller in France. And the person will have to take responsibility for on behalf of the insurance company. And so the idea is that in order to take responsibility, in order to be sure, the person will ask for tests to be made and other analysis. So in the end, the project will become a bit more expensive, a bit longer in time, and there will be more negotiation. So if you have those documents, then things go more smoothly. And so we had 3 of them. All of them are for the compressed blocks. To be honest, at the beginning, we wanted to obtain one for the extruded panels, but we were not ready for that. The R&D was not ready, so we just had 3 for the compressed blocks. The one on the left is the most obvious one, because it really takes advantages of the characteristics, the qualities of earth, and it does not put earth outside where it can be more fragile. So it's basically walls within a building, for example, to separate two rooms in the same flat or 2 flats, one from another. And so depending on what you are using it for, you can have, I don't know if I can zoom in a little bit or not. It doesn't look like. So you can have just 1 layer of bricks, or you can have 2 layers of bricks with an acoustic insulation in the middle, or you can have 1 layer of bricks, acoustic insulation, and a plaque of gypsum. And you have all of this on our website, and there are much more detailed drawings if you want to have a look. So this was the first use. The second one was on the external envelope of the building, but on the internal side. And the idea here was especially to take advantage of thermic inertia and also of the good acoustic properties, especially when it comes to low frequency, which are the frequencies of the street noise. And then the third one was the least obvious one, because it's like an added material. It's like a material that has not a lot of functions. It's more for visibility. And actually the drawing is not very accurate because it's going to be used mostly on the ground floors, especially in reception halls. And it's more to make the earth visible itself. So you can have this material, the 9.5, it's like small bricks for cladding. And you can use it inside in reception halls which have higher ceiling. And the whole idea about this was that when a builder, a project owner, makes an effort to put a new material into his building or her building, they will want the material to be visible. So when we first went to meet project owners and we said, okay, the best use is inside when you don't see it, They were not happy at all because they said, well, when we go to see the mayor and we want to file the building permit and our project is a bit more costly because there is earthen materials inside, then there's no advantage for us if it's not visible. So that's why we decided to have at least one use that was especially thought, especially designed to be very visible. None of these uses is load-bearing. We can have, people can build with our materials, with low-bearing projects, but it will be on a small project in maybe 2 or 3 floors maximum. And also the thing is that we wanted, most projects that are being built today in Paris, in the Paris region, is 4, 5, 6 stories. And also, if you want to have load-bearing properties, then you have to go thicker. And in Paris, the cost of each centimeter is very high. So for the moment being, we didn't see a very great advantage in having a special use for load-bearing walls. It can be used from people, but then they will need to have their own tests to prove that it works. And I said that these documents are quite expensive, and I'm talking about 150,000 euros per document. So it's quite a lot of money. So another material that they are selling, sometimes I say we and sometimes I say they because I don't work for Cycloterre directly, but I'm one of the founders of the project. So one of the materials that they are selling is plaster. And at first they had only one shade, and now they are trying to develop different shades. And here you can see some samples of use in Paris, in a shoe store. And now recently they added a new material, so they are pre-formulated soil for rammed earth to be produced directly on site. And as I said, there is a product that is being developed now. It's extruded panels. We had wished to develop it during the European framework, but we were too late. So we found some new money later, some new funds, and now it's being developed this year. And here I wanted to talk about something that has become very important for us, because the new regulation, the environmental regulation, changed in France in 2022. And this was quite good news for us, because now for each building permit, for most constructions, even for one house, you need to have a life cycle analysis of the whole building, taking into account all of the materials. And the whole process, the whole life cycle analysis must respect, must not be higher than a certain level. And of course, this is different according to the project, the surface, etc. And this has been very good news for us because it's making our materials much more interesting than they were up to last year. For example, I had one architect who is not an architect, actually, it's an engineer, thermic engineer. She called and she told me that on one project, they were about to file the building permit, but with the new regulation, they couldn't do it because they were too high. And they just changed the paint, and instead of the paint, they put plaster, Cycloterre plaster, and just by changing the paint and replacing it with plaster, it became good for the regulations. So this is really good news. So here you have a comparison of 5 types of walls. On the right, the two you have on the right are very common walls that are being used in France a lot. And on the left, you have 3 different compositions using raw earth materials from Cycloterre. When you compare the life cycle analysis of one material to another, at least in France today, it's not very interesting, meaning that it's not very advantageous for our materials because it's more or less the same. A block of compressed earth has more or less the same carbon footprint, according to the databases, as a concrete block. So it's a little bit strange. It raises a lot of questions, but that's the state of things today. But it becomes more interesting when you compare walls, because then you can take advantage of the fact that the earth can play different roles. So in some cases you can use fewer materials, or you can use, for example, less thick insulation, etc. Or you don't need paint anymore, etc. So I'm going just to describe them a little bit. The first one on the left is compressed block from Terre, of course, with earthen mortar, 9.5 centimeters. Then you have extruded fiber earth panel with earthen plaster on both sides. You have wooden cleats and a bio-based insulation. Then you have extruded fiber earth panel, the same thing, but you have metal studs instead of wooden cleats, and you have glass wool insulation. And then you have two more conventional walls that are used a lot, especially the one on the right. It's a traditional wall with 2 layers of paint, gypsum plaster on a gypsum panel, and then you have glass wool insulation and metal stud. So I've been talking quite a lot about the factory, but I haven't said so far who is running it. And while we were working on the project, we had planned to give the keys of the factory to an industrial actor, to someone else actually. We wanted to find an industrial producer and just hand him or her the keys of the factory and then do something else ourselves. But at one point, it started to be apparent that we were too attached. Many of us, we were so attached to the project and to the values of the project that we didn't want to just give it to someone else who might not want to respect the same values. And also the city of Terre was very attentive to the use of public funds. So we wanted to make sure that in the years to come, the public funds that were used for the project would be used in a good way. So finally, we decided to create a cooperative company ourselves in 2020. And I wrote as a title, Out of One's Comfort Zone, because none of us had any experience at all in industrial production. All of us had very different jobs and skills and qualities, so it was very new. And in 2021, we hired the first salary person, Teddy Dussaucet, who is general director, and who luckily enough had some experience in industrial production. And now he has his own staff. It's 6 people altogether for the moment. Just a few words on the business model structure. So the sale of earthen materials represents about 85% of the revenues of the turnover. And as you know already, there are a few materials which are already available: compressed blocks, mortar, plaster, and mixed rammed earth. And then they are developing extruded earth fiber panels. And then about 15% of the turnover is brought by consulting and engineering, so soil characterization, consultancy for specific projects, and then some workshop and training sessions. And I talked about this with a producer from Brussels, BC Materials, and it's funny because for them, I think it's just the other way around. It's a reverse proportion. I think most of their business model is based on consulting, and they have a little bit of production, which gives a lot of visibility. So it's a safer business model. Here it's more risky because you will see now which is the yearly productivity. And when we started the project, there was virtually no market in Ile-de-France, in the Paris region, for our materials. So actually the European funding gave us the possibility to launch an industrial production for which there were no customers. So now there are a few. The yearly productivity of the factory is about 600,000 units for the compressed blocks, so about 20,000 meters square meters walls. For the panels, it's about 60,000 units. And then plaster, mortar, and rammed earth. Sky is the limit because it's a very quick production. The soil does not need to be, the material itself does not need to be dried. After the production is very quick, and then it can immediately go to the building site. So if the demand is higher, they will be able to produce more materials. And today there is one team with 2 production workers and 1 workshop manager. And so in order to increase production, another team should be hired, which is quite easy. Less easy, they will probably need more drying space. So probably they will have to find some space close to the factory to dry the materials. So this was the first part, and now very few slides left to talk about what has been the impact of Cycleterre on the earthen construction sector in France and where does it stand today. So as I said, when we started, there was virtually no market in Paris. I counted about 6 buildings in Greater Paris using raw earth between 2017 and 2021. If you know the Paris region very well, maybe you will spot there 1 or 2 are missing. I'm not 100% sure about this, but I'm sure it's definitely fewer than 10. And this was between 2017 and 2021. In 2022, Cycleterre delivered quotes for 154 different building projects. So this gives an idea of the increase in the number of projects using earthen materials in the Paris region. And in January 23, 29 quotes were delivered for a total budget of 800,000 euros. So it is a small economic sector. Compared to conventional materials, it's really a drop in the ocean, but it is growing. But then the question is, do we want it to grow? And as you may know, the French love a good debate, so there is a lot of discussion, a lot of debate going on about do we want the earthen construction sector to become more industrialized, to be massified. Here you have the logos of 2 NGOs, which are the most important ones in France, Confédération de la Terre Crue and Aster. So Confédération de la Terre Crue, originally it was builders, mainly builders, craftsmen, artisans, and they have a very positive stance towards craftsmanship. And Aster is a bit more composite. You have different types of professionals that are within Aster. There are even people who are cement producers, who are members of Aster. But still, I think most people in France try to preserve the artisanal qualities of earthen construction. So when it comes, for example, to stabilization, most people, including Cycleterre, are maybe not totally against stabilization, but think that it should not have a big role in construction. And Aster published a lexicon for earthen materials, for the earthen sector, and they defined terre crue, earthen materials, as something that has no binding agent. So they wanted stabilized materials not to be called raw earth materials. And so there is also an opposition between standardization on one side and diversity on the other side. So the idea that if we have people who are experts, they will be able to valorize diversity of soils and to apply the right technique to the soil available locally. And if you go towards homogenization and standardization, then you will need fewer skills on the building site, actually. It will become more a mechanical gesture to do. And so it will be maybe less interesting from a skills development point of view. And then there is an acronym that is very much used in France. So it's BTP, which means Bâtiments et Travaux Publics. So it's the whole construction sector. It's building and infrastructures. And when you talk about the economic construction sector, you will say always BTP. And now there is a new version of it, which is bois, terre, paille, so wood or timber, earth, and straw. So I don't know exactly where we are going now. I don't know which way the whole sector will take. There are some tendencies to go towards massification and to put a lot of earthen materials as much as possible in order to lower the carbon footprint of the buildings. And so let's say the Cycloterre and maybe Brick Technique Concept are more on this side, and then other people are more on the craftsmanship side. And of course we talk to each other, and most of the time we are very good friends, but still there are differences. So it's really difficult to say where the sector is going today. There is quite a lot of work being done. There is a national project, it's called Projet National Terre, which is going to last 5 years, and they're going to work on many different topics. There has been the publication of good practices, guides. There is a norm that was approved 2 years ago. As I said, there are experimental appreciations, there are environmental appreciations. There is a lot of training and skill development. And as I said, there is the new environmental regulation. So it looks like quite a lot, and compared to 5 years ago, it is quite a lot. But maybe you should know that in these two entities, these two NGOs, each one of them has only one salary person, half-time. So there is not a lot of money already yet in the construction, in the earthen construction sector. So most of the work is being done by volunteer people. Now I'm just going to show you a few pictures from projects that have been developed recently in Paris or near Paris. Some of them use Cycloterre materials and some use other producers' materials. So here you have a very beautiful day hospital by Tolila and Gilliland. A private housing project using rammed earth, which was produced on site. And here the same architects are building a new project, but in this case they are using prefab rammed earth panels from a new producer in France, Terre, which is based near Lyon. A very beautiful building, especially, I haven't visited yet, it's being built now, but from an environmental perspective, this building will have no heating system at all, and they're using materials from Cycloterre. A new media center from Nicolas Miesner using poured earth panels. A building, a high school building that is now being built using materials from Cycloterre. And as far as I know, they are using stabilized material on the outside. So this is the only project, as far as I know, where Cycloterre accepted to sell the materials for use outside without any roof, any balcony, any protection at all. And so they wanted to do the project like that, and they wanted to change it at all. So they sold the materials, and they had to apply for a new certification themselves, as it's a new use. So this is going to be an entertainment center very close to Sevran. This is going to be a very beautiful project by Toa, the same architects who built Myriam Makeba in Nanterre. It's going to be social housing with adobe bricks on the outside, protected by balconies all around. A school with Cycloterre blocks. And here it's difficult to imagine, but there are earthen materials inside. It's going to be a sports venue for the Olympics in Paris. And so the last big question for me and for all the people who have been working on Cycloterre and those who have been financing Cycloterre is will one production site will be enough? So we took some ratios that were produced by Urban Planning Institute in Paris. They said that between 2025 and 2030, 33 million square meters are going to be built or renovated. So we took 20% of that and we applied a ratio of 1.5 wall per flat. We imagine that it's all flat and that we're going to put 1.5 wall inside each flat using earthen materials. And if we had that, then we would need 30 factories of the same size of Terre in the greatest Paris area in the years to come. So this is very unlikely, of course. I don't think we are going to have even five of them in the years to come. But we are in a very strange situation because, to be perfectly honest, the factory as a private company is not out of danger yet. So it's a new company. As I said, there was no market when they started production and they started selling materials. So although they do have clients, it's still not enough to give a total stability to the company. And in maybe 1 year time, it might be not enough. So the transition, I have the intuition that the transition is going to be very, very short. We'll probably pass from a situation where the production is more important than the demand to a situation where the production or the demand is much, much, much more important than the production. And probably more people will come to create new materials. But this is just an intuition and we will see what happens. Thank you.
Thank you very much, Silvia, for this very inspiring lecture. It's just amazing what you have done within a very, very short amount of time. I mean, building the factory, starting the production process, doing all this research besides. So it's really amazing. It's a question where the future goes and if handicraft is important or industrialization. But probably we have to come from all sides and do it all at the same time. We cannot say what is better or worse. It's good that Earth is there and that we use it on all levels. So congratulations again for this project. I think it's very well known here. So many people are talking about this project because it's one of the first one that has this kind of mass production that we are all talking about when we are talking about Earth today. And it's kind of strange to hear that you don't have customers. I would have thought that people come running to you and they want your projects and they know about and they're curious to hear more about it.
They do. The thing is that, as you all know, from the moment where an architect decides to put a material into use and the moment when the building company comes to buy the materials, it's at least 2 years. So that's the difficulty. So there, as I said, in January they had quotes for 29 different projects. So there are lots and lots of customers. But when we started to produce the materials, the customers who were coming were architects, and they were coming for projects that would be built in 2 years' time. So that's the time lapse is the problem. Not the interest itself. I think they had. It's impossible to count, but I had thousands of visits since the factory was delivered, and so many people are interested, and they really want to use the materials. So there is a lot of interest, that's for sure. It's going to explode, but as I said, the time lapse is the problem.
And in order to expand, because we had Mrs. Fröhlich here from Germany, unfortunately you didn't hear her lecture, but they are using like industrialized projects or like like construction sites that are already there, where before there were other products produced there, but the machinery is there and everything is there, the automatization project. Yeah. So is this an option to maybe use other infrastructure that is there already, other machinery, just in order to expand?
Yeah,
this?
absolutely. And it reminds me also of what Terre is doing in in Switzerland. They are doing some industrial co-working. They are using for a few days a year industrial facilities that are already there, and so the cost is very low because they don't have to pay for the machine investment. Yeah, so it's really absolutely a good model. For us, it was a very special project because we had all this funding from the European Union, so it allowed us to do something that it is very visible, very well known. I was talking to a communication expert some time ago, and she said that she had never seen a project where there was such a strange ratio between the level of interest and the level of investment, of money that was spent on the project. For her, this is a very small project that has received a lot of media coverage and a lot of interest. But of course, so it was good that we did it this way, but of course there are many options to do it in a way that does not require so much money.
Are there any questions from the audience? Maybe? Everybody seems to be quite tired after a whole day of lots of information that we gained today. Well, if there are no more questions, I think it's time to finish. Christina, would you like to say some finishing words? And thank you again, Silvia, for finding your way from Paris to Vienna.
Also, a very special thanks to Silvia Devescovi for coming here to present your factory. Und vielen herzlichen Dank an alle fürs Kommen, fürs so lange Durchhalten, fürs Dabeisein, fürs Mitdiskutieren. Ja, und wir freuen uns auf die nächste Lehmbautagung, wann auch immer sie sein wird. Ich lade Sie jetzt schon dazu ein. Und bis dahin bleiben Sie uns gewogen. www.netzwerklehm.at, dort finden Sie alle relevanten Informationen. Wenn Sie den Newsletter noch nicht abonniert haben, dann können Sie das auch über die Webseite machen, beziehungsweise über eine E-Mail. Ansonsten bleibt mir jetzt nur noch, Ihnen einen wunderschönen Abend zu wünschen. Bleiben Sie dem Lehm treu, machen Sie den Lehm zu einem Massenbaustoff, in welcher Form auch immer. Vielleicht gründen Sie auch eine Fabrik. Ja. We will see. Schönen guten Abend und Dankeschön.